Hi lads, in this video I'm going to go through the 2018 higher level question 6. It tells the figure shows a design for a toy loading shovel. The curve ABCD is a portion of an ellipse with major axis AD. Point B is a point on the curve. Determine the length of the minor axis and draw the ellipse. The curve UB with vertex at U is an identical portion of the same ellipse. The line BT is a tangent to the ellipse at B. The curve KMN is a parabola with a vertex at M. Draw the given design showing clearly all constructions and points of contact. So to start this question, I'm going to start off with the ellipse given. So I'm going to draw a line there across from my axis, and I'm told the length of the major axis is going to be a total of 160. So I'm going to set it that it's going to be 80 out to this side and 80 out this side. And let's draw my vertical line. And then I have to figure out my minor axis. I'm also given my focal points. So I'm not given my focal points. I'm just given the major axis and a point on the curve. So the point on the curve is actually up 24 mil. If I take that line across, I then need to go across 66 to get that point. So there's a point in the curve. So this question, they give me the length of my major, they give me a point in the curve, and that's all the information I've been given. I have to find out the rest from there. So what I can do is I can draw in my major circle there. And then what I can do is, on the side here I can draw a small sketch as if I was actually about to do the question. So let's just say that was my major circle, and there's my minor circle. If I just find a point in that curve, after dividing up, I take a line out at an angle to hit the major circle, I drop it down, take a line across, and there's my point. So what you can see there, what I did was, I took a line out, down and across. I took a line out to actually hit the actual major circle. I dropped down to find the point and took it across from the minor circle to get that point there. So I'm actually given the point. So what I can do is, I can copy what I've done here. I can take my line up to hit my major circle. That connects back to my centre. And where that line goes across, just like this here, it gives me a point on my minor. So now I've actually found my minor circle. So it's just using the information you have to try and find out what you're missing. And that gives me my minor circle now as a result. After that then, I can start drawing out the rest of the ellipse. So I can use my 30-60 for each of my points here. I won't bother taking another 30-degree point out there because I already have a point in the same sort of area. And now I can start drawing my points. So all the top half, they all drop down like this, and they all go across. And that gives me all of these points here now. And now it's the exact same for the bottom half. Take my lines up. And then take these ones across here as well. And now I have a series of points on the bottom. When I have all that drawn then, I can then nice and neatly draw in my freehand curve. I'm making sure to draw it lightly first, and then I can go in heavy after I figured out exactly what part of the curve I want to keep. Because you can see part of the curve in the question isn't actually required. So I'll just leave it like that for now and have this light section here. After that then, I can draw on the wheels. So you can see from the major axis there, we go down 32. I can take that line across. And then what I have is a radius 27 circle there for the outer wheel, for the outer part of the wheel. So that's going to be there's a radius 27 from this point here. I step in 27. So there's the center of one wheel there. And the other wheel is on the same line at the 66mm point here, which would have given me point B. So I can take that down, and where that hits the baseline there, that gives me my other centre there. So what I can do now is I can take my radius 27 and I can draw my wheel there, and I can draw my other wheel in here. And there are my two wheels now drawn in. And then the internal one is going to be a radius of 12. So take 12 there. And take 12 there. And that gives me the wheels now complete. There's then a line coming down, so I'll just show you there. The line coming down at 10 degrees there. I can draw that in lightly. And it comes from the wheel here. So from the centre of that wheel, take that 10-degree line there. Take it out lightly like that for now. And then I can start to draw in my parabola on the left hand side. So with the parabola, from this point here, I'll just extend it out here, we go out a further 49mm to get to that point there. I'll draw a straight line up there, and then the length of it is going to be 65. So I can just take the wheel on the ground there, and take my 65 from here, take that straight up there, and then it's a total of 75 up there then. So 75 up here, and my parabola is going to fit inside this box here, with the vertex being at M, which is going to be located along the halfway point. So the first thing I can do is actually bisect that line to find my centre point. So there's point M, and there's point K, and there is N. So for the parabola, what I'm going to do is I'm going to divide the sides into 4 equal parts. So take a distance on my compass, step it out 4 times, and then use sliding set squares to get the sides. I can take those across to the opposite side, and then we divide half of our side here into 4 equal parts. So we're going to have 4 equal parts here and 4 equal parts here. So 1, 2, 3, 4. Same idea again. Connect those two together. And what I can do now is I can take this distance on my compass, step across 1, 2, 3, and then 4 left over there as well. So for all the side ones, the vertex is the top there then. So our side measurements connect there. And our point, we're going to have a point here, a point here, a point here, and the opposite side we're going to have a point here, here, and there. And then I can draw that in. So nice and neatly draw your curve in freehand. Just like that there. And then the part that's heavy, for that there is a line at 75 degrees. So I can just set this to 75 there. And from that point there in, and what it does is it just cuts off that section there of the parabola, and the rest of it then is just drawn in heavy. So that's the parabola drawn in. Now for the tangent. So the tangent occurs at point B, so it's a point on the curve. We're told already that the focal points are determine the length of the minor arcs and draw the ellipse. So we're not given the focal points, so what we need to do is take half the major and we swing it from the minor. It gives us our two focal points there and there. I'll just label that F1 and F2. And we're drawing a tangent to a point on the curve, so at point B. We connect the focal points to the point in the curve, and we then bisect that angle. That gives us our normal, and we know that our tangent is always perpendicular to our normal then. And that gives us our tangent line there. And we can see then the rest of our ellipse is heavy around to the wheel there. And then the whole base, which is this section here, it's heavy between the two wheels there and there, eliminating that part of the ellipse now. And the front goes all the way around until the 17mm line comes out here. Take that 17mm line up, and what you'll have then is you'll have it heavy around to there. I'll draw the wheels in heavy after, and then the last part is to draw in the portion of the curve up here as well. So along that 17mm line we go up 24, and at this point here we have the 45-degree line taken like that there, and that line goes straight up a further 60mm up here. That line extends all the way up to that 60mm height there that's given, so from this point up 60, we'll cross our 17, and then what happens is we're going to take this section here, that's part of an ellipse, so you can imagine cutting out a section here, turning that side and drawing it in there. It's like cutting and pasting something somewhere else. So the main thing we need to see is that it's a minimum of 60mm down to there, but you can see it's going to step a little bit lower to hit off the section on the opposite side. So what I'm going to do is I'm going to take about 70 mil maybe of this section of the ellipse. And what I'm going to do is take that as if and turn it around up here. So the easiest way to do that is take 10 mil sections like this here and mark them down here as well. So 10, 20, 30, 40, 50, 60, 70. Take them lightly across. And I'm going to take these up as well, and I'll show it with colour as well what I'm actually doing, just so it makes sense. So the first 10 mil section here that I'm going to be taking, I'm taking this section here and I'm going to apply it to here. So what I've done basically is that green length there is that green length there, and all these divisions in between, they're all equal. Them blue sections are all 10 mils, so I'm saying it's that distance there, same as that section there as well. So the next one then, I'm going out to the 20 mil, hits the ellipse there, step that out to there, go to the 30 mil, hits the ellipse there, step it out to there, 40 mil, goes to there, 50 mil, goes to there, 60 mil, goes to there, and the 70 mil, let's check there, make sure I get the right point for 70, should be the last one here. That distance goes to there. And what I've now done basically is drawn that portion of the curve there. Oh, forgot to take up the rest of it there. And now I can draw my freehand curve down to where it hits the actual ellipse, and then I can draw on the rest of it there in heavy. And that's how I basically do it. I'm taking this section here and moving it up to there. So all these blue sections are equally 10 mil spaced apart. I went down to about 70 mil. You can go 80 mil if you want to. You just get another point inside here, and all I do is draw heavy up to where it actually hits it. So show an example again. When I step in 10 mil, I took that green distance there. Step in 10 mil, applied that green distance there. Then for this one here, for example, if I step 10, 20, 30, 10, 20, 30, this one here, I took that height and I applied it to there. And now the last thing to do is just draw in heavy my 10-degree line there up to that point, and then draw on my wheels heavy. And that then completes the question. So the main thing to remember from that, apart from what I did up here, is to remember to draw a sketch. Sometimes it helps you. So by drawing that sketch of how to actually find a point on an ellipse, it helped me actually determine the minor circle, and also then I used the method where you take half the major and swing it from the minor to get my two focal points there and there. They're the key things you need to remember. And then for finding a point to a tangent, or find a tangent to a point on the curve, connect the focal points to the actual point on the curve and bisect the angle in between. That gives your normal there. And if you go perpendicular to that, you get your tangent then as a result as well. So hopefully that video helps anybody who might have been stuck on that.